Hello students, and welcome to today's lesson on inscribed angles and arcs. Our objective today is that we will apply theorems about inscribed angles and special segments using journals. So our first four theorems will be specifically about inscribed angles. So, an inscribed angle is an angle which has its vertex on the edge of the circle. So it's any angle that has a vertex on the edge of the circle like we've defined before. And so, if we have a general inscribed angle like this, then what we'll see is that there's a relationship between my arc measure here and the inscribed angle here. And that relationship is that the measure of angle B is equal to 1/2 of the arc measure AC. So, in this case, if I have an arc measure of 80 degrees, then my inscribed angle will be 40 degrees. So pretty simple. My second theorem is going to be about a pair of inscribed angles. So if I have this angle inscribed here, and then I have another angle inscribed here, and we'll call these points A, B, C, and D. All right, and what we learn is that if two inscribed angles intercept the same arc, then those angles are congruent. So, if two inscribed angles same arc, then they are congruent. So again, if we say that AB is 80, then each of these angles down here will be 40. All right, and then we have two more inscribed angle theorems, so theorems that will just deal with our inscribed angles. All right, so theorem 3 says, if an angle is inscribed in a semicircle, then it is a right angle. All right, and let's go ahead and see what that looks like. So if we're inscribing it on a semicircle, which means that we take a diameter and then my angle will connect right here, like so, then it'll make a 90-degree angle. And that makes sense because this is a 180-degree arc, right? A semicircle is half a circle, and half a circle is going to be 180 degrees because the whole thing is 360. So half of 180, this is a natural consequence of our other theorems, will make a 90-degree angle. All right, and then theorem number 4, if a quadrilateral is inscribed in a circle, then opposite angles are supplementary, or they add to 180. And again, this is going to make sense. So if I choose these 2 points here, right, and I'm talking about this angle, then that angle is going to be half of this arc, and then its complement, or its supplement, will be this side, and that will be this arc over here. And what do we notice about those two arcs? Well, those two arcs make up the whole circle, and a whole circle is 360 degrees. So if we're taking half of each of those measures, it makes sense that we'll end up at 180. So we have, over here, we can have 95, 85, here we'll have 110, and here we'll have 70. And this also is an interesting fact about quadrilaterals in general. It's not just a quadrilateral inscribed in a circle that will add up like this, but any general quadrilateral. So if a quadrilateral is inscribed in a circle, then opposite angles are supplementary. All right, now we're done with our inscribed angles theorems, so your next theorems will be on your cutout that you received. All right, so now looking at our theorems cut out, we have theorem number 5, the tangent and chord. So remember, now we're starting to work with different special lengths. So we have a chord, and we have some line which is tangent to that chord. All right, and what we're going to say is that the measure of angle C, so we'll go ahead and name this point C, name this one point B, and we'll name this one over here D. All right, and this theorem simply states that if I have this angle here, angle C, that the measure of angle C is equal to 1/2 the arc BDC. So what we would say is that we've got this arc here, and the angle measure for angle C will be 1/2 of that arc. So if I say that the measure of arc BDC is equal to 90 degrees, then my measure of angle C is equal to 45 degrees. Theorem 6 is about lines intersecting inside of a circle. So we have our circle here, and we have these two lines which intersect. And what we'll say is that if I know that one of these angles, we'll call it measure of angle 1, and notice it's not passing through the center, so we'll call this angle number 1. What we see is that the measure of angle 1 will be equal to some measurement of the arcs. So if we have this arc here, and we call it X, and we have this arc here, and we call that Y, then the measure of angle 1 is equal to 1/2 X plus Y. So if we go ahead and call X 85, and we go ahead and call Y 25, then what we see is that the measure of angle 1 is equal to 1/2 85 plus 25, and so the measure of angle 1 is equal to 55 degrees. All right, and then last but not least, we have theorem number 7, which is a theorem about lines intersecting outside of a circle. All right, so in general, we say that the measure of angle 1 is equal to 1/2 X minus Y, where X and Y are going to be two of those arcs again, similar to what we saw on this page here. So you saw X and Y were on these opposite sides, and now we're going to see those used again in this circumstance. All right, but now our lines are intersecting outside of the circle. So we actually have a couple of different ways that this can happen. So the first situation is where I've got a secant and I have a tangent. And so my larger arc will be X, and my smaller arc will be Y. So you have X and you have Y. So we see that the arc is created where each of the lines passes the circle, or where they have an intercept with the circle. So that'll determine where your arcs will be separated by, is where the lines pass by the circles. So this is one situation where this will occur. You will apply the measure of angle 1 is equal to 1/2 X minus Y if you have an intersect between a secant and a tangent that's outside a circle. You'll also apply it when you have two secants, so that would look a little bit like this. So now I have two secants that are outside of the circle. And again, the larger arc will always be the blue, or I'm sorry, will always be the X. And then the smaller arc will always be the Y. And then finally, we have the situation where you have two tangents. And you guys already know a little bit about this situation because you know what happens as far as the lengths go of these tangents. So if you have these two tangent lines which meet out in space somewhere, you already know something about the lengths of the tangent segment from here to here, right? You know that those are going to be congruent. But now we also know something about the arcs. You know that the measure of this angle here. And let me go back and put this in. The angle that we're measuring here is at the intersection. So this intersection here is angle 1 in each of these cases. So the measure of angle 1 here will be, again, 1/2 x minus y, where x is this larger arc and y is this smaller arc. All right, so we've got a few examples for you guys to do, so go ahead and take a moment to do the examples that go with each of these theorems. Once you're done, go ahead and move on to the next slide here in a couple of seconds, which is your reflection question. All right, so given the circle below, identify the name of the theorem that you would use to solve. Explain using your vocabulary listed for today. So make sure that you're using the right theorem here. So if I were to ask you to find x in this circumstance, what theorem would you use to find it? All right, let me know if you have any questions and have a wonderful day. Goodbye.